Hello everyone, this is Akshay from the team Hopeful Initiators. For the Smart India Hackathon 2023, the problem statement we have chosen comes under the category of student innovation with the code 1474. So have you wondered what happens to the plastic water bottles that we use and throw every day? Where does it go? So most of them ends up in landfills and incinerators, so where they take hundreds of years to decompose. This is a major problem the world is facing. So our idea is to convert these plastic water bottles, so which is mainly composed of a chemical called a polyethylene terephthalate, so abbreviated as PET. So our intent is to convert these PET water bottles into useful fabrics. So for which we have derived a solution. So what do you think is the need to convert these PET bottles into useful fabric? So by converting PET water bottles into useful fabric, it reduces the negative environmental impact these bottles pose on the environment. Second, it's a fun and creative way to make your own clothing and apparels. Third, the process is relatively inexpensive, and all these three would be achieved can be achieved with the model we have brought up. So as mentioned earlier, the water bottles we see everywhere, we carry everywhere, is made using a chemical called polyethylene terephthalate, so which is non-biodegradable. So we intend to collect these plastic water bottles, segregate them based upon their color, and process them to make nice-looking T-shirts and a lot more useful fabrics. At the initial stages, cleaning the bottles is necessary, to which can be achieved with the help of a vacuum pump, and shred them into small pieces, melt those shredded pieces and turn them into fibers. So the technology backing up our innovation is optical sensors, which we have used to rightly detect the color of the bottles and segregate them. Then comes the spinneret, which turns the molten PET into fibers. So you see, the apparel made out of PET is eco-friendly, which is a testament to sustainable fashion. The apparel greatly suits for the athletic persons or sports wear. As it possesses a property called moisture wicking, so which is nothing but transporting the moisture from the skin to the topmost layer, which is the third layer of the cloth, and then the moisture evaporates from there to the atmosphere. This is the team of hopeful initiators who made this wonderful idea possible. Each contributed in a different sense and gave their fullest to eventually bring up this model. Coming to the 3D model, so the 3D model we have made using Blender. So you can see we have three different machines involved here. So this is the first one. The first one is the shredder machine. So this is not like an default shredder we have in those industries. This is a totally different one. So we have to load the pre-crushed water bottles through this loader, and they come down to the blade spot. So here we have multiple layers of blade. We have just given 2 blades just for an example, but we'll have 4 to 5 layers of blades rotating at almost 1000 to 1500 rotations RPM. So these blades are inclined at an angle of 35 to 45 degrees to make the best cuts to shred those water bottles to finer pieces. Shredded pieces fall upon the conveyor and they come to the metal tray. So from this metal tray we'll be loading into the preheated oven. So this is the preheated oven, which will be preheated at 250 degrees Celsius. So that is the point at which plastic starts to melt. So once the plastic pieces are now in molten form, we'll be loading the molten peat into the spinneret machine. So the spinneret machine contains a small device called spinneret. So the role of the spinneret is to convert the molten plastic into uh, very small fibers of the diameters range, which is almost 0.1 millimeters. So such small fibers are obtained at the end of this process. Next, these fibers, multiple fibers are combined to obtain a thread. So then the thread is with the help of a yarn, it is manufactured into a t-shirt, fabric, and more based upon the needs. So thank you. This is our model.